Okay. Okay, guess I'm going live again. Thank you all for watching. So now let's look at, so where was I again? Okay. PC outlook for tomorrow looks to be, this is the one I was issued this afternoon, so I'm going to be going to bed in about an hour. Slight risk for the Northeast. However, I think a marginal may have to be issued for the New York City area. Or a slight. I think there has to be a slight that needs to be issued for the New York City area. I would honestly cut this slight to encompass only northern Connecticut. I don't think Massachusetts should be in the slight though. Let me look at the models for tomorrow and I will, let me see. Okay. Yeah, maybe Massachusetts needs to be in the slight. Let's look at the the NAM 3KM. Looks like, based on this model, I would put Massachusetts in the marginal, Southern Connecticut in the slight, or even enhanced, maybe an enhanced, or keep it as a slight, because it looks pretty likely that there's going to be some damaging winds tomorrow. It looks like there's going to be a widespread damaging wind event tomorrow. Okay, let's see if the live streaming is working. Okay. Yeah, live streaming is working, but I'm having issues with the site now, so okay, try that again. Oh, wind gust, this is what I wanted to see, wind gust, okay. They're showing winds up to about 60 miles an hour, close to 60. Could be a bit stronger, but I would say slight, I think, is appropriate for tomorrow. I think enhanced is a little too much, because here's going to be the winds for tomorrow. So you'll be having a southwest wind at the surface. Ooh, yeah, so there will be shear. Ooh, guys, there's going to be shear tomorrow. Close. Yeah, there's going to be shear tomorrow, guys. I mean, wait, sorry, that's, nope, I don't want to see that sounding. I'm going to see the one just before. Boom, right here, right at this moment here. This is when we should be looking at the shear parameters, because you're having a southwest wind at the surface, northwest flow aloft, northwest and southeast flow aloft, southwest and northeast wind at the surface. So you'll definitely be having shear tomorrow. There is definitely, absolutely going to be shear tomorrow, and marginal severe. Let's look at the wow, jeez, that is a lot of convection. Oh my god, that is a really high convection. That is a very high. This is the dry adiabatic lapse rate, or moist adiabatic, yeah, dry. I believe blue, it is the moist dry abat, and red is the moist. Yeah, so this is the moist abat, and this is the dry. So definitely conducive for severe weather tomorrow. Wow. Yeah, definitely conducive for severe tomorrow. I mean, it's gonna be pretty humid, so I'm gonna think something like this. So you'll have wet parcels going up to 500, so that's almost 20,000 feet. And then you're still having this, so the dry adiabat is going through the roof. I mean, wow. That is a big lapse rate right there. It's a very unstable environment tomorrow. Or, yeah, this is very unstable. Jeez, just look at this convection. I mean, that is really high, but that's the moist adiabat. The dry adiabat only goes up to about 500, and it doesn't, so low level lapse rate is going to be very high tomorrow. Very high low level lapse rate. But look at that. There's going to be a good chance of hail tomorrow. So about 27% chance of hail. So Looks like the main threat actually may be hail tomorrow. And look at the wind barbs. Definitely shear. Definitely some shear. So hail is going to be the primary threat. Could be some wind too, but there's definitely going to be hail tomorrow. Not so much a tornado threat. It's like marginal. Yeah. But also a good chance of hail tomorrow. 152 loose matches. SARS is 27% significant. So yeah. Good chance of hail. Now we're going to change gears and look at the West Coast now. Now what is on tap is the West Coast. So let's go look at the Great Basin, which is basically California. Actually, I prefer Southwest because it gives you all the cities in the Great Basin. So yeah, basically the Central Valley region. It's what I want to be looking at. Let's look at that. 105. I mean, look at Death Valley. And jeez, I'm looking at but this is only going out to Thursday afternoon when I'm going to be in Boston. So looking at the GFS, looking at the Southwest, and look at this, 120 degrees, approaching 120. It dropped slightly, but not by much, 118. So there's going to be a historic heat wave. Let's look at Fresno. Keep in mind, Fresno all-time high temperature, 113 degrees. Yeah, look at that, 114. Hottest day recorded in Fresno. 115, so yeah, Fresno may just clinch that record, but at the airport, the high temperature was 113. Be it mild, rainy winters. Yeah, very Mediterranean, but hot Mediterranean. This is like, it's almost nowhere in the world. This is a true Mediterranean climate. Hot summers, hot dry summers, cold winters. I mean, cool, mild summers. Yeah, they have to open cooling centers. They have to. And they have to be powered by renewable energy. So like if there is a power outage, the cooling center can run under its own power. And also, yeah. Anyway, I just want to... Oh, wow. Let's look at last year. Shatter heat records. Okay, 130 degrees. Look like last year's the same thing. What is the hottest? How much? Okay, 134 degrees. So, mess it above. 2 degrees higher than the old records. So last year, all-time record highs. This year, all-time record highs. 2 years in a row of breaking all-time record temperatures. Never happened before. The sweltering heat is hitting our neighbors too. Fresno. Yeah, 100. Hit 12. Yeah, 112. Oh, look at that, guys. 114 now. Every year it's just getting hotter and hotter and hotter. So much for climate change being a hoax. Yeah, take that. Yeah, take that, all you climate deniers. What are you going to say now? Oh, it's just a weather pattern. It's just a weather pattern. No, it's the weather pattern plus all the carbon that's going in the atmosphere. The planet's warming up. Yeah, I'm sorry. I'm just going to go on off a little tangent, talk about climate change. I'm going to talk about the volcano in the Philippines, which is going to blow. It's going to blow. I'm sorry to say this, it's going to blow, but let me talk about that later. June 2021. Global anomaly. Yep, and let's look at Dr. Roy Spencer's page. June. Oh yeah, negative 0.001. Oh yeah, but it's no longer 1979 to 2010. Everything keeps on going up. Look at this. Whoop, whoop, whoop. Everything is going up and up and up and up. I'm sorry, but climate change is here to stay. This is not COVID. Oh, it's going to go away in 2 years. No, climate change, this is much graver than COVID, much graver than anything else, and climate change could start a pandemic worse than anything we've ever seen in history. How about smallpox being released from the tundra? I mean, from permafrost. How about all these viruses that we've never seen in millions, hundreds, thousands of years, tens of thousands of years being released? You know, we have to wake up to a new world that stuff like COVID will become common now because of climate change. COVID was because of how we handle animals. This was because of, you know, what happened at the wet market. But we could be having huge releases of, you know, viruses, you know, whatever is trapped here and here all across the Arctic because of global warming. Also methane release, which will accelerate climate change, you know, global warming, but at very rapid intervals because methane only lasts in the atmosphere for a certain amount of time. But also Pinatubo yesterday emitted 4 days worth of America's, actually 5 days, 5.2 days of all of the United States emissions of sulfur in 1 day. But that's very unusual because Mount Pinatubo usually, Taal doesn't emit that much, and this is a record for Taal. Sulfur is also a coolant on the environment. Sulfur, if it goes in the stratosphere, actually cools, not warms the planet. But look what happened. Sulfur emissions dropped from 22,000 to 5,299 tons. That is such a rapid decrease after such a rapid increase. It is very dangerous. That means that there is starting to be some pressure being built, especially since you're still having harmonic tremors. Right here it says, including 2 volcanic tremor events. So 2 harmonic tremor events having durations of 3 to 5 minutes, and that's not good because that is indicating that there is some magma movement towards the crater. You know, if you have a very short duration harmonic tremors, that usually means it's close to the surface, especially if it's a high frequency. So there's been instances where harmonic tremors right before an eruption. It's a frequency. It's not which way the magma is moving, just the frequency of the tremor. The tremor indicates how fast that magma is moving, the movement of the magma. Now, which way it's moving, if it's going up or down, but how fast it's moving, or how close it is to the surface, possibly. So right here is boom, harmonic tremor right before a volcanic eruption, you know, at Redoubt volcano. But keep in mind, that's a stratovolcano, not a caldera. Calderas do not follow the same parameters as volcanoes. In fact, I've been looking at Taal just before it had its eruption on July 1st, and here's what I noticed. There was very rapid duration harmonic tremors. Yesterday there was 45 minutes, today durations of 3 to 5 minutes. 39 volcanic earthquakes. 2 hybrid earthquakes, and low-level background tremor. Yeah. So 39 volcanic earthquakes. And let's look at the day before. You know, this is looking at yesterday. Remember the 22,000 tons? Look at that right here. 22,628 tons, and you had how many earthquakes you had? 17 earthquakes. Today you're having 39 earthquakes. So you basically more than double your amount of earthquakes, yet you reduce the amount of sulfur that you're emitting. Not a good sign at all. Very, very bad. I am very concerned about Taal right now. If this stayed high, that would be a good sign that the volcano is degassing, releasing the pressure. You know, that's what you want to see. You do not want to see this. You definitely do not want to see this. You definitely do not want to see this. Absolutely do not want to see this. Going from 22,000 tons of sulfur to 5,000 tons of sulfur. Huge decrease. just a giant decrease. That is a decrease of about 85% in one day. Let's look at the percent. That's about roughly 80 to an 85% decrease. So 22,568 minus 85%. Okay, so about I would say not about, okay, I'll say 75% decrease then. So it's near 80% still. It's still really high. 22,628 minus 75%. Yeah, more than 75%, because I did 75 and I got 5,657. So rounded up, you get 80. So close to 80% reduction in sulfur emissions, just in one day. Yeah, the amount of earthquakes are increasing. So look at that. 17 volcanic earthquakes, 1 harmonic tremor with a duration of 45 minutes, and 16 low-frequency volcanic earthquakes. And yet, you have, this is today, 35 low-frequency earthquakes, 39, okay, so you have 39 volcanic earthquakes, 35 low-frequency volcanic earthquakes. So you have 39 volcanic earthquakes, or are they counting the other, or this is total including this? So you have 39 volcanic earthquakes, including 2 volcanic tremor events of 3 to 5 minutes, 35 low-frequency volcanic earthquakes, and 2 hybrid earthquakes. So yeah, big increase from yesterday. So 17 and 16, and now, or is it this is 16 and this one, but either way there's an increase, including 16 low-frequency volcanic earthquakes. So it's probably this and this. Okay, so it's 16. Okay, so it's not 39 plus 35 is 30. So it's okay. So you're having 2. Yeah. So it's okay. So it's not. So this is the total, and this is the breakdown. 35 low-frequency volcanic earthquakes, 2 hybrid, and 2 harmonic tremors. So total 39. Okay. So it went from 17, so 16 low-frequency earthquakes and 1 harmonic tremor. So now you're having 2 harmonic tremors, yet sulfur emissions are going down. But these are brief harmonic tremor events. I mean, there's definitely pressurization going on. The volcano is now repressurizing at this moment, based on what I'm seeing now. There's definitely a pressurization of the edifice, probably at the main crater. So it's probably going to be an explosive eruption, I would think. In a few hours, there's probably going to be another phoratomagmatic eruption. Could be a big one. Probably enough to send a ash plume 10,000 feet, I would say. It may be phoratomagmatic initially, or it may be a very sudden, very explosive eruption, and the crater lake may drain, and then you'll have a long duration explosive eruption. I mean, Tau has one day erupted like crazy, and it was like a years long eruption. So, and they're saying that magma shooting from the main crater could drive an explosive eruption. The public is reminded that the entire Tau volcanic island is a permanent danger zone. Good, yeah. And I would definitely evacuate anyone near the lake, the entire lake, because the entire lake is a caldera. Also, I think they should expand the evacuation zone to beyond 5 kilometers, because this is a very dangerous situation, in my opinion. And such a decrease in sulfur is, you would think it's a good sign, but it could be that there's a blockage that's developing. So let's do a Pinatubo. Let's look at Pinatubo. I just want to show you a Pinatubo documentary. think this is the one I was talking about.
The outskirts of Angeles City.
Big Mendoza is about to go into labor. Clark monitors the sulfur dioxide levels over the summit. For 2 weeks, they hold steady. Then suddenly, they plummet. It can mean only one of two things. Either the magma has subsided and Pinatubo has called off its attack, or it is blocked and pressurizing.
You hear that?
A gigantic powder keg that could blow catastrophically at any moment. Ray has to make the call. Is Pinatubo going up, or is it going quiet? It is an awesome choice to make.
Yeah.
An eruption could happen in a day or a decade. Volcanoes do not keep the time of men.
We know the stakes are high. We don't know how long the fuse is. You have to work fast.
With the tragedy of Nevado del Ruiz in Colombia haunting him, Ray decides the moment has come to call his enemies bluff.
A more climatic eruption that will soon occur.
He finally orders a general evacuation of the provinces around.
But here's the thing. They didn't know that Pinatubo. They knew that Pinatubo has had VI6 and like really big eruptions, and it hasn't blown in over almost 1,000 years or several. Yeah, so it was really pressurized. But even with Tau, you still could have a huge supply of magma, and even these small eruptions may not release the pressure enough. And the fact that you had a record amount of sulfur and then boom, decrease, it's not good. Really
Pinatubo. The call goes out to almost.
This could be the one. This could be another global catastrophe waiting to happen. This Tau eruption. I actually had a feeling that Tau may have a VI7 one day. I just looked at it. I'm like, this is not good. Why did I say that? Was because the last eruption was 1977, and historically Tau erupts very often, like intervals of 5, 6. On average, no more than 10-year intervals, and there's still massive, big eruptions. And now, you suddenly stopped having eruptions for what? Over 40 years, and then the last eruption before that was in the 1920s. You're starting to have these big gaps in eruptions that even when that historic eruption happened in the 1500s, 1600s, you didn't have these huge gaps. And the thing is, Tau could have a large eruption, possibly Plinian. I mean, I was thinking, oh, maybe it's not going to be so big, but what I'm seeing right now is really concerning me. Tau is definitely giving mixed signals. There is a chance it may not erupt. It may just quiet back down, but something is going up. Maybe this is a brief decrease, but if it continues to go down and down and down and nothing happens, and you're still getting those quakes, that means magma is trying to go out somewhere and it's not going out. And they're saying that the summit crater is not really pressurizing, it's actually subsiding. It's not uplifting, but the caldera region is uplifting, but the summit crater there's been subsidence since April 2021. That means that there's magma that is going away from the main crater to somewhere else, and that other areas are repressurizing. That's what it's leading me to believe. Or it's going to another volcano, because I believe that Tau shares a large underlying magma chamber. Like, of course, Tau definitely has its own magma chambers, under the edifice, but there's also larger magma chamber. There's very likely a large magma chamber under all these volcanoes here. So you're having a triple subduction zone. Not all of the Philippines has subduction, so not all the islands have volcanoes. But here's the thing: you have the Manila, you have the Manila Trench here, which runs here along the west coast of the Philippines. This is the most active part of the Manila Trench, right here. Then you have the Philippine Trench here. So this trench here, this subduction zone, is the Eurasian Plate subducting under the Philippine Mobile Plate. And here you have the Pacific Plate subducting underneath the Philippine Mobile Belt. So this is and then you have the Sunda Plate subducting under the Philippine Mobile Plate, which causes these volcanoes here, like Tagabud, you know, and also you know, Matum. So, and then you have, so Mayon is caused by the subduction of the Pacific under the Philippine plate, while the Tal, Pinatubo, Laguna Caldera, Banashaw, and, you know, as well as Batan are all caused by subduction of the Eurasian under the Philippine mobile belt. So you're having two subduction zones, basically. So basically, you have a transform, like a mobile belt here. So this is what used to happen here. This is basically what happened on the West Coast about millions of years ago, and it's repeating itself here now in the Philippines. So this entire region could have a large underlying magma chamber. I don't know if this could be the resurgent dome. I mean, this looks like a resurgent dome if you ask me. Resurgent dome right here. I mean, look at that. I mean, this looks like a caldera. I mean, doesn't have a circular shape. It kind of has a weird shape if you ask me. But I think this whole area was one caldera, and you're having uplift here. This is where you're having uplift, and this is not because of high hotspot. So it will be erupting in the same place basically, but like in this general area, you're not going to be having a trail of hotspots. I mean, trail of calderas like you do here along the Snake River Plain. Let me show you topography here, and you could actually make out the Snake River Plain here. Oh, sorry. Let me look at the topographical map. Okay. Looks like I lost it. Okay. Yeah. Also prompts a 5% tornado. Yeah. Oh yeah, and by the way, yeah, this is what I wanted to show you guys, but you know, some time already passed. So let me upload it again. Yeah, so the Philippines are gonna have a massive eruption. Tal is gonna blow sky high. Tons. To Anyway, let's go back to what I was talking about. Okay, guys, so let me focus on the weather for tomorrow. Let's look at wrap for tomorrow. Yep. Wrap doesn't seem to be too concerning. Let's look at spaghetti models of tropical tidbits. Just want to look a little bit at. So I already finished looking at all the models for the tropicals, for the tropics. 50 degrees, just. Middle East. 51 degrees Celsius. Oh, jeez. 52. That's going to be about 100 and 25 degrees. Jeez Louise. 125. Yikes. World records are going to be shattered. Like, it's... Oh, God. I mean, every year we're just going to be shattering all-time record highs. It's going to be, oh, no more 1934. It's going to be 2022, 2023. Jeez. Yep. Global warming is starting to rear its ugly head, guys. It's already happening. It is already happening, guys. Let me make sure I'm doing this correctly. This can't be. That's crazy. I mean, formulas, right? Conversion from Celsius to Fahrenheit is roughly 1.8 plus 32. You know, or for anomalies, if you want to find the temperature anomaly, it's just that times this. I'll show you the temperature anomaly. So, then if it's 4, or like, if it's 4 times, yeah, so it's like, yeah, so, alright, so let's look at this now. There has to be, like, let me try to look there. Yeah, it's that, those values are maxed out. Maxed out values. Look at this. Regions. Western United States. Again, almost maxed out values. Right, look at this. And then the Middle East. Come on, give me the Middle East, please. Yeah. Oh, God. Oh, jeez. European model. Oh, yeah, they don't show that. They don't show surface temps. Oh, wait, that's right. Tropical, pivotal weather. I forgot I have pivotal weather. Not a, how to year pivotal weather. Alrighty. Okay, close. Okay, let's look at European model. Let's look at the 12Z, and let's look at Middle East. I'm looking at 2 meter temperatures. They're not giving me 8 surface temps. It's weird. Anyway. Great, hobbyist. I may soon have to be doing the professional plan. Because very soon I'm going to be doing forecasts for all over the world. Yeah, the reason my forecasts are really is because I have to run everything myself. Also, I'm really busy. I don't have time. So my family calls me like 10, at least 7, 8 times a day, and I'm... Okay, anyway, I need to be planning better, so... Thing is, I live with other people and they usually distract me and I get calls, so that's why I cannot do recordings because it just stresses me out. I have to worry about people calling me too much. It's just really, really stressful. So I don't even know what's the correct software to use, or anyway, let's look at close. Okay, alrighty. Look at that. Oop, they extended the slight just as I thought they were, but they did not lower the slight. But they did extend it south, which I did anticipate. That is correct. That's what I would have done too. Hail is still there, but they did extend the wind. They basically kept everything is about the same. They just extended the slight further south, basically. But the slight still is in Massachusetts, when I don't think that Massachusetts should be in a slight, in my opinion. Here's why I don't think Massachusetts should be in a slight. Because, I mean, they're probably doing it because of these storms here. I mean, this is why they were putting it in a slight, I think. Yeah, maybe, I think, okay. But the NAM nest is showing storms developing south of Massachusetts, so yeah. Anyway, I'm really concerned about Tal, and let me look at Florida. I think they may have already issued a tornado warning because enough time has passed. I'm going to be going to bed in like 10 minutes, so I'm about to end the stream. Oh, great news. Wait. Rotation has dissipated. But there's another area of rotation that's going towards South Miami, so it's going to be a really active night for Miami with possibility of tornadoes tonight and tomorrow, so keep an eye out. And now I'm going to go to Tropical Tidbits, tropicaltidbits.com. So 52 degrees, so definitely in the high 120s. So yeah, there's a chance that southwest Iran may hit all-time records. And this is exactly where they drill for oil, so yeah, it's not looking good. Those workers are going to be sweltering out there. All these workers, geez, this whole area is just going to be in mind-boggling heat. Let's look at North Africa. Jeez. I mean, well, hot weather is normal for North Africa. Oh, look what's going to happen. Extreme heat, and then boom, cold front is going to come in. So, okay, look at that. So, extreme heat. And then basically a brief cool down because it's going to stay in the 90s. Look, you're going to go from hundreds to 90s as a bit of a cold front is going to seem to come through. I think, yeah, a bit of a cold front, but not much precip with it. And a lot of wave activity. Wow, a lot of waves coming off of Africa. However, this is really early for hurricanes, because hurricane season doesn't gear up until August, so I think we're going to be on par of like 2005. SpaghettiModels.com, let's see. Oh, sorry, I was supposed to go to Tropical Tidbits, but I was looking at models instead. So let's look at satellite imagery. But it did just make landfall in Cuba, so my guess is that there's going to be less, it's going to be kind of, disorganized. As you can see, it looks very disorganized. And it also looks like it's being sheared apart a little, so there's a lot of convection developing to the south. So if this can wrap around, if this convection can wrap around the center, you can get some rapid intensification, but it looks like it's going to go up the Florida coast and probably make landfall in a couple days. But yeah, it did get kind of shredded by Cuba, which is a good thing. Okay, so I guess this is it. Thank you all for watching and have a great night. Let's pray that Tau does not erupt. Let's hope that it does go quiet back down. I'm really concerned because this is in a very populated area. I mean, looking at Tau, looking at the Tau volcano, you can see where it's located. It's located around several towns, including Lipa, and to the north is Manila. So Manila is a big city. So if you have a Plinian eruption, you're going to have heavy ashfall in this whole region. Keep in mind, Pinatubo is well north of Manila. It's located, I believe, Mount Arayat. Arayat volcano is a potentially active stratovolcano. Yeah, you do not want to hear potentially active, because this could be one of those Pinatubo type of volcanoes that sit quietly for thousands of years and then they really just go crazy. You want to like dig and look for pyroclastic flow deposits. You definitely want to drill in the region around to make sure there's no pyroclastic flow deposits extending more than 10 kilometers in any direction. If you find pyroclastic flows extending more and they're less than 2,000 years, and you look at the intervals, you gotta look at the intervals of those pyroclastic flow deposits. You gotta do that. Because Pinatubo, they were able to look and find the pyroclastic flow deposits before its climatic eruption, which is why they were able to...
A million people. Then suddenly, they plummet. It can be on the magma beneath the surface.
What I'll do is, see that first little ridge line up there? I'll try and set it up so we can run up about there and make a left.
Apparently, I wasn't subscribed to this guy.
Down to this ridge line here.
But the chopper is ill-suited to the task. Its rotors churn the air and confuse the detection instruments.
I love that too.
Let's drop down here.
I'm trying to see if I can find a Nat Geo.
Almost a million people.
You want us to keep flying around looking at it? Yeah, we gotta make sure what it is. Let's drop down. Okay, coming down center, use the throttles.
He finds sulfur dioxide, tons of it, escaping from the volcano's vents. There's no way of telling how close the magma is to the surface, but the sulfur dioxide is his first real clue that an eruption could happen. But what he cannot see or...
This entire town was built after the eruption of Pinatubo. You can see almost everything here is probably modern, very modern architecture, or was probably built right on top of the 1991 flow deposits. You can see the new building here, though some older looking building here. Like, it looks pretty old, but this is all probably constructed after 1991. So these are all new. Everything here you see was built likely after 91. Because keep in mind that Pinatubo unleashed massive pyroclastic surges that actually overwhelmed the U.S. Air Base in the area. So Mount Pinatubo right here. Angeles. Yeah, let's look up Angeles. The town's probably already there to begin with. History then. History. Let's look at the history. American period. Pinatubo. There was a lot of damage in Clark, and this is what happened in Clark because of all the ash, and also a pyroclastic surge. While the pyroclastic surge didn't really like hit the base directly, there was a lot of damage because of collapsed roofs, as you can see, damage from heavy ashfall, all ashfall related damages. So, and Clark Air Base was located, I believe, let's try to find where, Clark Air Base. So Angeles was given, and also you had a tropical storm hitting at the same time, which made it a absolute disaster, complete and utter disaster. Like, if there was no tropical system at the time impacting Angeles, it probably would not have been so bad. I mean, it very likely would not have been so bad. How in the world did I end up on this side of the street? Wasn't I on the other side? Yeah, Google Maps is very confusing. There we go, that's the car I wanted to look at. Definitely looks like a Toyota Highlander. It's probably called something else in the Philippines. I think it's called, okay, that's a Hyundai Accent. You know, anyone could like tell what that car is. Hyundai Accent, a Highlander, I believe. But it's called different names in Asia. Could also, I believe it is called something else. Anyway, let's exit. So this will, okay, yeah. Okay, let's look at this. So this is where the volcano was. And this is only about 20 miles away. So Clark Air Base, and yeah, right in the town of Angeles. So yeah, significant damage. Was, yeah, a lot of collapsed roofs. So they probably either put new roofs up or completely rebuilt a lot of structures. So pyroclastic flows, I believe, raced down this river. This is where the pyroclastic flows likely went down. But pretty far from Manila, I would say about 50-60 miles away. Definitely had ashfall, but Tal is in the Philippine metro area. I mean, I wish I could just turn this map. I don't even know how to do it. With Google Maps, like on my phone, I could just, zoom out and twist the map, but I can't really, I can't do that with this device. Enable globe view. Enable, okay. So I'm enabling globe view. Yeah, so globe view just lets you like see how you see everything turn. You can almost see the bulge of the earth a little bit. Anyway, Clark Air Base, very close to the Philippines. I mean, to Pinatubo. About 10, a little more than 10 miles, I would say. It's the kilometers. So a little bit more than 20 kilometers, about 25 kilometers. And so Manila is about 40 kilometers north of Taal. So that's good. It is far. It is pretty far from the volcano. So I had to estimate Manila is about about 60 kilometers north of Taal, about 60 kilometers. It's about 60, so that's pretty close. I mean, that's like, what, 40 miles? So that is pretty close, but because some volcanoes can send up pyroclastic flows up to 40 kilometers away in some rare cases. Or if it's a super eruption, up to 200 kilometers away. So if this was if it erupts with its normal, like a Plinian eruption, VI5, VI6, you would have pyroclastic flows going out to about these areas. Not base surges, pyroclastic flows. Base surges are a type of pyroclastic flow. Base surges are more because of how they travel along the water. But you could have a what is known as a column collapse type pyroclastic flow, like when the column loses its height and then it collapses. That's kind of what a base surge is, because of column collapses. So you could have base surges that go up to about this area, or you could have base surges that could engulf this entire region, especially if it's a more powerful eruption. Especially if it's a flat area, there's no, a lot of type pyroclastic flows go downhill and then they slow down when they go uphill, but there's not much uphill to go to. I mean there's some uphill, like even some pyroclastic flows can actually race up smaller hills. For example, when Krakatoa had its climatic eruption, a pyroclastic flow went up to so when this volcano had its climatic eruption, oh wow, it's no longer considered a park. Remember that all these islands were green? Not anymore. They took them off park stat, or maybe they did that because it's no longer considered forested. Green, I think, means forested satellite. Krakatoa Island is still really forested. This island looks barren. How? Oh yeah, because of this volcano, very close proximity. tsunami from this collapse right here. That's all because of the tsunami right here. See? Jeez, that's from the run-up. Wow. It's all the damage from that tsunami. The one that happened December 24th, 2018. Still, damage still visible. Look at that tsunami scar right there. Incredible. It's from here. Anak Krakatau. It's no longer a mountain, it's now a crater. And it wasn't a caldera forming eruption, it was a landslide. Basically the entire half the mountain slid off. Basically the whole mountain slid off. You had a 1,000-foot mountain, it was building itself up, and then just slid right into the ocean. It's a fog. Oh, look at those clouds. Basically hugging the mountain. Isn't that cool? But you cannot. There's another volcano. Sabisi Island is probably this whole area probably has one big magma chamber. Possibly, maybe not. But it is pretty close. It's about a 30-kilometer. Cebuco Island craters there. Probably an ancient volcano. This is probably a more recent volcano here. It looks like a caldera here. I mean, let's see. But keep in mind, this whole area was one big volcano. So you have one. So this is basically 3 volcanoes. So it could be one underlying magma chamber. Could be a couple of magma chambers. I mean, basically this volcano is formed by this subduction zone right here. And you see that little kink right there? Little kink right there. Boom. That's where there's extra subduction going on, basically. There's a little kink in the subduction zone right here. Boom, kink right there. And this area is one big volcano, actually. And Samosir Island is actually a resurgent dome. And there's 2 volcanoes here, Sibuatan and Sinabung, which is basically right here. This is Sinabung. These 2 volcanoes all share a magma chamber with Toba. So, similar magma chamber, because guess what? The ash linked to Sinabung is the same chemical composition as Toba ash. So, same exact chemical composition, which means same magma chamber. So, same magma chamber. You can also, like, the chemical composition is the same. Not just the composition, but like but the chemical footprint. Like it could be basalt, andesite, but you look at the type of ash, and you could determine if it came from the same magma chamber or the larger underlying magma chamber or the shallower one too. Level of free convection, low, let's see, L, level of free convection. Lifted condensation level, okay. LFC, or lifted condensation level. So, level of free convection, so a lot of convection. Yeah, there's a lot of, yeah, a lot of, yeah, so your environment is definitely going to be warmer than normal. While the, okay, so, well, this is the moist adiabat, this is the dry adiabat, so, based on this, I'm going to go right now to, let me try to, this is incredible. Oh my gosh. Got a lapse rate for tomorrow. That was in 21, 107. Oh. So you're basically, so sorry, this is the moist adiabat, or dry, this is the dry adiabat right here. going all the way up to this is actually the moist adiabat. So wow, so you're gonna have potential ecotops all the way up to exceeding 13 kilometers. 12, so look, so 9, 10, 11, 12, okay, should be having going up to like 13 kilometers. Okay, M2 feet. So 12 kilometers will be, so about 40,000 foot tops. I mean, let's see. So let's try to do the math, I guess. Let's look at, okay, so this is 12 kilometers here. This is 15 kilometers here. So let's see, about 14 kilometers. So just below, let's say, okay, 13.5 kilometers, just to be safe. 13.5. So you'll be having ecotops exceeding 40,000 feet tomorrow. Pretty impressive. I mean, the moist adiabat, I mean, the dry adiabat is only showing up to about 20,000 feet. You know, or, you know, 500 millibars is roughly at just about 5 kilometers, just under 5 kilometers, just about 5.2 kilometers. So, about 10,000 feet here, and 20,000 feet, of course. Sorry, this is close to 20,000 feet here. 5.2 km to feet. About 5.5 kilometers. Yeah, so it's not 20, it's just under 20,000 feet. So you're definitely going to be having a lot of stability tomorrow. Quite a bit too. Let's check out the mid-level lapse rate for tomorrow, and they probably go with the dry adiabats. Usually, if the atmosphere is drier, it's less conducive. So usually lapse rates, they want to convective mid-level lapse rates. Tomorrow, not too much, but it's actually pretty impressive today. Let's see. Mid-level lapse rates are pretty impressive today, that time, but tomorrow, yeah, for that you want to usually use the NAM, convective mid-level lapse rates. Low-level lapse rates. Yeah, of course it's going to be really, oh yeah, very high lapse rates tomorrow, but of course, but look at that. An inversion for the moist adiabat. So look, cooling, warming, and cooling. So an inversion, temperature inversion. Whereas dry adiabat saying it's going to be going up. None. No quality matches for tomorrow. So let's look at the mid-Atlantic. Let's be looking at convective. Let's be looking at CAPE for tomorrow. Convective inhibition. Nope. Okay, this is what I want to be looking at. The most unstable CAPE. CINH. About 3,000 joules per kilogram. That's right, 18Z. Let's see what they're showing for tomorrow. This is not based on the NAM nest, this is based on the NAM itself. This is slightly lower resolution. Jeez. Also showing marginal severe, 29% significant chance of hail, but showing small hail, so not showing large hail, showing smaller hail. 50% chance of tornado, but marginal severe. Very impressive lapse rate. That is a lot of instability. I mean, look at this. Look at this entire, look at all the space. Like, parcels just go, wee, wee, like, rise, go up, let's go, let's go. And oh, this is when you'll have your pause. But if you can get a strong enough puncture, it's not just going to be boom, immediately stop. It'll probably continue to rise until this cools down. So, well, it's not just going to suddenly cool off. So the parcel will probably continue to rise. So I'll say about 15, 16 kilometers before it probably will just peter back down. So keep in mind that tomorrow looks like it's going to be a pretty good chance of some really impressive convection, especially the temperatures being in the 90s at the surface. So you'll have, you know, pretty impressive lapse rate tomorrow, all the way up to about here. But this is the big kahuna, the moist adiabat. This is the dry adiabat right here. The red is the dry, this is the moist. Jeez, a lot of instability. I mean, if you have a temperature inversion with this, so if you have the blue crossing the red, like what I showed you earlier, that's going to prevent any, so then you'll have elevated convection possibly, not surface-based. Tomorrow any convection we do have definitely seems to be surface-based. You're going to have surface-based convection tomorrow, absolutely. Because there's no inversion, there's no temperature inversion tomorrow. Look at this, it's just going to be going whoop, whoop. However, a little bit there is. The moist will be ahead of the dry, so, and then it's going to basically, the moist and then will overtake the dry, so you'll have faster convection. Either way, very unstable atmosphere tomorrow. Very, very unstable. It's going to be really unstable tomorrow. Primary threat, I'm going to assume, is going to be damaging winds. Let's look at helicity now. This is what you want to see for tornadoes. Was impressive now, but no helicity at surface. Elevated helicity a little bit, but really low. It's actually going to decrease. So can't really say anything about tornadoes inland, but you could get a spin up because of, you know, offshore wind, but also that's when you have the most the cooling winds. You have cooling winds off the water right here. So let's look at National Data Buoy Center for 4025. Probably about 70 degrees. 71.6. Wow. So water temperatures are warming up slowly but surely. Slowly but surely, they're finally starting to warm back up. 71, so 73. This is about what it was last year this time. Let's look at this time last year. Oops, sorry. That's not what I wanted to see. Water temperature. Okay, this is not what I want to see. Yep. Nope. Not this. Forgot 44025. Does not. It is giving bad data. here's a problem right here. Yeah, I'm having an issue because see 99999. It's just gonna say 99. Oh wait. This is what you want. Water temperature degrees Celsius right here. July. $27 degrees, 27.5 right here. Look at that, 27.8. This is pretty far off the coast too. This is like 20 miles off the coast. Never ever seen temperatures that warm in that particular location. This is just unheard of. 82 degrees. I don't even think that's the warmest it's been. Yeah, I even hit 84 at one point. 27, 27, 27, 25, 25, 25, 25. Come on. Yeah, see, that's the problem. Unavailable data. Yeah, unavailable data. Yeah, 99999 means unavailable. Okay, this is now July 31st. This is, and then it started. Oh, look, that's because of the tropical storm that went through. Remember? This is after Hurricane Isaias basically pummeled the New York City area, and then took some time for the temperatures to warm back up. I don't think it ever got back up to the level it was before. Stayed in the low 70s, low to mid 70s, basically. And it stayed that way for most of August. So I'm looking at the basically August. And look at that. Even in September, look at this. In the mid to upper 70s. September 10th, 24 degrees Celsius. That's like 77 degrees. It's like very warm. It's in the mid to upper 70s there. It's like 75.6, 7.2, yeah. Very, very warm. And at this time last year, July 6th, water temperatures were a little cooler, I mean warmer than they are now. So we're at July 6th right now. So 23.8. So yeah, 74. So we're a couple degrees cooler this year than we were last year. Speaking in terms of ocean temperatures. Yeah, so a lot of thunderstorms tomorrow, and as you can see, hail, good chance of hail tomorrow. Oops. Okay, I'm going to bed now. In Atlantic. Anyway, gotta go to bed now. Thank you all for watching. Good night, everybody. I'm gonna be shutting off the computer now. Closing out all my windows. Thank you everyone for watching, and good night.